Hello guys, welcome back to my channel. So today we're going to talk about black holes. What are black holes? Black holes are regions in space where gravity is so strong that nothing escapes it, even light. Anything that goes in gets trapped. So it's a region with a strong gravitational attraction. So once light is trapped, it means you can't see anything because light doesn't come back. Now, how are these black holes formed, or what are they really? They are corpses of dead stars. So during their lifetime, the stars were burning hydrogen to helium. Hydrogen was a source of energy, source of fuel, and in that there was mass that was pulling and there was energy that was pushing. So the energy that pushes, or that was pushing, prevented the star from collapsing under its own weight. So when it burnt all the hydrogen, then there was no longer energy to push it outward. Then the star collapsed onto itself into a neutron star if it was 3 solar masses, and if it was more than that, then it fell into a black hole. Now the solar mass is the mass of the sun. Okay, so if it fell to a black hole, now what we are actually talking about, then it forms something called a singularity. The singularity is a point where matter is compressed infinitely to a very tiny point. Dense point that attracts so strongly that even time and space does not escape it. It becomes meaningless. They are intertwined, that time takes space and space takes time. So it's really, even laws of physics break down here. There's no explanation to it. So around this singularity, something else around it forms called event horizon. Now event horizon is a point of no return for anything that goes in. It disappears and it's not seen. It's cut off from the external universe. So here we have something like quasi-Charles radius, which measures this, and it defines that quasi-Charles radius is a radius below which the gravitational pull between particles in a body must cause it to undergo gravitational irreversible collapse. So around, I think I'm going to use a diagram to show you a bit of it. So around the event horizon, we have the photon sphere. So this is a singularity point. Matter is here, center concentrated to infinitely to a tiny point, and then the density is so much. And then here we have quasi-Charles radius. This is the event horizon. This is something that I've just drawn to show you. And then outside here we have the photon sphere. The photon sphere, photons are almost massless. So they come very close to the black hole, and then they form a ring around it. They go around, and due to this, they try to go out to escape, but they're trapped by the strong gravitational field of the black hole, and they lose energy. So in the process, their wavelength lengthens to a red side of the spectrum. So they lose the momentum. That's the moment of inertia and the angular velocity. Now, in connection with this, we have something called accretion disk, which is forms around here, whirling and swirling of plasmas electromagnetic waves, particles, all the stuff that comes close to this. And these things move so fast, the speed of light, almost the speed of light around this area. But as they lose energy, then they spiral inwards towards the singularity. Now, according to this black hole thing, there are many hypothetical hypotheses or theories that have been theorized over the centuries, over time. Like in Newton's, we have Newton, we have general relativity, we have uncertainty principles, Compton wavelength, all these apply here, and Planck's constant. So let's start with Newton. What does Newton say? Newton says that all matter in the universe attract each other with a force which is proportional to the product of their masses and inversely proportional to the distance, the square of the distance between their bases. That's Fg is equal to G m over I think r squared or c squared. I'm not clear about the formula. So away from the black hole, this thing called black hole obeys the laws of gravity. So away from here, where the gravity is not so strong, the laws of Newton works here. Excuse me a minute. The laws of Newton works here. I don't know whether this can show you. Everything is clear enough. No. So we're talking about this as a black hole. So away from here, things will cycle around this area. Obeys the laws of Newton. But as soon as you go, or when you go closer to the black hole, then Newton laws does not apply. That means they can orbit, objects can orbit around this astronomical object, which is a black hole. But when it goes close, then it does not work. We have relativistic, it's general relativity that takes over. Now, general relativity states that what we see as gravity is due to a curvature of space and time. So gravity has the ability to work on space and curves it. Okay. So once it is curved, then things have to travel through the curves. How long the curve is, or how short the curve is, where things like geodesics come in. Geodesics is the length minimizing curve, the shortest path in a curve. How much is it curved matters. Okay. So that's as far as general relativity is concerned. So how many types of black holes? No, before that. So how is that effect felt? Like if there's an observer who's outside somewhere, outside here, sitting outside there in the universe. Sorry, I have to keep showing you this. Let me see this thing, whether it will show you properly. No. Here we have our gravitational lensing. We have the photon sphere. We have the Hygosphere. If somebody is somewhere there, for example, here, and is watching time here, you'll see that time goes slow. This is what we call time dilation. Time goes slow when it goes towards this area of event horizon. And even the light, if you shine the light towards that area, it becomes frozen in time. Yeah, that's how strong the gravity is. So the person who's observing this will have a different perception of time than the person who's actually falling there, or whatever that is falling there. So this thing gallops everything around it, stars, objects that fall there. They go in, takes in, swallows space around it. We have frame dragging. What happens inside influences the area around it. Okay. So there are various kinds of these the black holes. We have stellar, massive, supermassive, and miniature type of black holes. So some as old as when the Big Bang was formed, some formed later. As time goes on, the astronomical scales. So here I've shown you the Schwarzschild radius. Here is plasma electromagnetic waves. Okay, and there's something called Planck constant also. We have photosphere, we have egosphere. Egosphere is an area which is highly deformed by the gravitational pull of the black hole, such that something that is moving so fast can come in and go out. And then there's something called escape velocity. For something to escape from the black hole, it has to travel at more than the speed of light, and the speed of a black hole is 99% faster than the speed of light. You can imagine, because the speed of light is 300,000 kilometers per second. Yeah. So what's so interesting about this black hole, what the hypotheses say, what if down the black hole, down the singularity? Okay, let's start with somebody who's falling into the black hole. If he survives the plasma's intense radiation, which goes to millions of degrees centigrades, so intensely hot, and then falls into a singularity, and let's assume that the singularity is not going to spaghetti this person, because the gravity is so strong on the legs and less on the head. Then you pull him like a string, or her, or whatever that fell there. So let's say it's a person. So you go to the event singularity, and where there you encounter a wormhole. Then you extend through a wormhole. Then you end up in a white hole. That's like an alternative universe. So what happens there is that you find antimatter, which annihilate you because you are made of matter. That's alternative universe. So there are all kinds of theories, like there are stars inside the black hole that was formed later on. Those are just hypotheses. So we have something we call Planck constant inside this thing, which is given by the value of 1.6 to 10 raised to minus 35 m across, and that works down to something like 10 kgs or 10 raised to 35, where quantum gravitational effects are the same, and the Compton wavelength and the Schwarzschild radius are the same. So it's called Planck length. Yeah, man. So yeah, we're going to talk about what really happens inside the black hole. We have protons there, we have all kind of stuff going on. So we also have this black mass, which is 10 raised to power 8 kilograms, and we have a density have been enough to create a black hole, a mere 1035 meter across, a dimension known as the Planck's length. Okay, so we have types of black holes, I've told you, but in this case we are dealing with, so how far away is the black hole? The nearest to us is 1,600 plus light years away, and the 1 light year is about 9 trillion kilometers light travels in 1 year. Okay, so you multiply that times 1,600 plus light years away. It's so far away, so no threat. Inside the Milky Way galaxy, which is our galaxy, they sit a massive black hole called Sagittarius A. Now in a massive black hole, somebody can survive there in the event horizon for several hours, you know. So it's quite mysterious thing. Quite mysterious thing. So guys, I think we'll talk more about this. This is enough I have to show you today. And this thing form. Look, it looks like this. This one, let me point like this. This is what called gravitational lensing. It's caused by the cluster of galaxies, which curves space so that light from a quasar, the brightest object in space, is bent and comes in contact, so that an observer who's around here will see like a lens. It's called lensing. So this is plasma. This is a plasma that's going around here. Yeah. So this is what a black hole is. And we talked about the neutron star. So what really neutron stars are? Those are with 3 solar masses. They don't fall below the neutron star because the forces in the neutron star can sustain them. Roughly speaking, let's just say briefly how these stars were formed, because they were formed out of hydrogen, helium, oxygen, carbon, lead, iron, and then now when hydrogen is off, still those other elements are there. So it's speculative what is inside really black hole, because nobody knows for sure whether there's even this singularity. Yeah? There could be maybe live streaming, maybe it's a gateway to another universe. Nobody knows really. So yeah, that's all we have to tell you today. We'll go further and see if there's anything else to talk about the black holes. We'll go to point B or point C of it. Okay. Now this is enough for today. Please subscribe to my channel, share, like, comment, and if you're out there watching this, please, if you think there's something that I've left, add on the comment so that you can explore this thing together. So guys, bye for today. See you again in the next episode. Bye.